Thanks, Domi, and hello, HashiCorp. I'm going to tell you a fun story about something which happened to us a couple of months ago that we'd not actually had to deal with before. So we received a support request from one of our Vault users that looked a little bit like this. Help, I've tried to add a password to Vault and somehow it's ended up removing all the other passwords. Can you restore this for us, please? And I was on support duty that day, so my first reaction was like, yeah, that's fine, they've accidentally deleted something, that's not the end of the world. Vault has this helpful key value undelete feature. Let me just remind myself how that works. And it was at this point that I realised that the secret that they actually wanted us to restore was key value version 1. So this is the older version of KV which doesn't have a helpful undelete feature. So my next reaction is best summed up as a combination of panic and oh dear. So we've been using Vault for quite a while now, and so we've got a lot of secrets in it. And a lot of those are actually still using the old KV version 1. And so as much as we've been evangelizing KV version 2, it's not really been the top of our users' priority lists to migrate stuff over. So it was only really a matter of time before something like this happened. So originally I let the user know, sorry, there isn't an undelete feature for this. This is KV version 1, but depending on how bad it was going to be, we'd at least see what we can do. So hello, my name's Davinhart. I'm a senior automation engineer at Skybetting and Gaming. I've been here for about 4 years now, which is about as long as we've been using Vault. My team looks after various things, but pertinent to this talk, we manage our Vault clusters, handle all the tooling and integrations, and some supporting services around Vault, and we handle all of our internal users who need help and support using the product. So, what was going on here? Writing to Vault and having it delete stuff instead sounds a bit odd. But I had a theory, and if you've been using Vault for a while, you might already know what's going on here. So, normal Vault behavior looks a bit like this. I'm using the UI here, and I have a secret that has just the one key in it. I'm going to add a new key to my secret, I'm going to save that, and we're all good. As an experienced Vault user, I know I've just updated my secret. And now rather than having just the one key, my secret now has 2. But if you're unfamiliar with Vault, you could be forgiven for not quite understanding what just happened here. So as a new user, you might think, hey, I'm in the secret test directory, and I've just created a new secret. And while it's fine if you have that misconception whilst you're using the CLI, using the UI, if we switch to the CLI, yeah, suddenly we're going to have issues. So, let's see what secrets we have in this secret test directory. Okay, we've got these 2 secrets, foo and bar. Let me just add a new secret to this directory and... oh, where have my secrets gone? So you see, it's an easy mistake to make as a new Vault user if you don't know the difference between a key and a secret. Or if you don't realise that when you're writing a secret to Vault, if you're doing something like KV put, you still have to specify all of the other keys, even if you only want to edit one or just add a new one. And there's nothing wrong with what the CLI is doing here. This is correct behaviour. You need to specify all the keys, otherwise deleting specific keys later could be messy. And while we waited for confirmation from our user that this is indeed what had happened, we were able to confirm it for ourselves reasonably quickly, just by checking our audit logs, which in our case we shipped to Elastic. Now there weren't any deletions on this particular secret, but we can see that there's been an update. And this is a good example of one of the reasons you should be using Vault's audit logs. It's not just this feature you enable because your compliance tells you to. You can do all sorts of useful investigation and even alerting based on these logs. Now initially, nothing too bad happened as a result of this. So services which relied on this secret either had it cached or just didn't need to access it that often. But then a few non-critical services started failing. The keys they were expecting to exist just simply didn't anymore. And that on its own was going to be a problem, but worse, if we didn't fix this issue soon, business-critical services would start failing that evening when they were scheduled to run. And that would not have been fun. So, what are we going to do about it? Now, I'd initially told the user, sorry, key value version 1, there's not a lot we can do about this, but if business-critical stuff is going to break, we at least need to consider all of our options. And the first, probably the obvious answer, is can they just recreate the secret from scratch? Could they just regenerate all those keys and then write it back to Vault? And yes, they could do that. but they wouldn't have been able to do that fast enough to prevent things from breaking. This particular secret had quite a few keys in it, upwards of 50, and so it was used in quite a lot of places. And it turns out the only central record of what keys the secret had was in Vault itself. So yeah, not only was it going to be time-consuming to regenerate all those individual keys, not knowing what keys were there to begin with, yeah, it meant that would take far too long. Okay then, can we just reset Vault to an earlier state? We've got backups, right, so that should be possible. And for some context, each of our Vault clusters is set up similarly to the HashiCorp reference architecture. So we've got some Vault servers, and we're using Consul as our storage backend. We also have enterprise replication set up in both DR and performance mode, replicating to our Vault clusters in other sites. But that replication can't actually help us here because, ironically, it's too good. The update to this particular secret will have propagated to those other sites almost immediately. But if you read through the reference architecture page, which you should, by the way, there's a lot of good stuff in there, and some of it we're not even doing yet, you'll find this bit. So to protect against corruption of data, you should back up your Vault storage backend. And this is supported through the Consul snapshot feature, which you can automate for regular archival backups. And that's what we've been doing. In our case, we're running these snapshots hourly on one of our Consul servers. And then we're storing several days' worth of these snapshots on an NFS mount. We're actually going a step further and we're shipping all of those snapshots to our disaster recovery site. And then we also have regular snapshots of the NFS mount itself at the storage layer. So yeah, we're good for backups. That's not a problem. So we can just take one of these earlier snapshots and restore Vault with it, yeah? Technically yes, but we didn't want to for a couple of reasons. And firstly, we'd lose everything that had been written to Vault since the snapshot had taken place. And we didn't know how much that would be. Or, more importantly, how much of that was important. So this was the middle of a workday, and we get approximately 1,000 updates to our Vault state every minute. So probably quite a few of those in the middle of a workday are going to be important. There'd also be some downtime. So to restore a snapshot, we'd first need to seal Vault, restore the Consul snapshot, and then manually unseal using our Shamir unseal shards. So yeah, downtime is inevitable. And it would also mean replication to our DR and performance sites would break, so we'd have to set that up again from scratch. So yeah, restoring Vault to an earlier state is definitely an option, but the impact of losing these particular keys would have to be pretty bad to justify us doing that. We didn't think it was. So ideally what we needed was the ability to travel back in time to before the secret was updated, have a look at what Vault was like at the time, read those secrets, and then bring that knowledge back to the future. And obviously we don't have a time machine, but hey, we have these snapshots, and they contain the earlier version of the secret. What if, instead of restoring those to production Vault, what if we restore one of those snapshots to an entirely new cluster? Now in our case, our Vault clusters run on VMs, manage those with Chef, and it's on-prem, and so it's not like we're having to build this from scratch, by hand. But we also don't need a full cluster. We could probably make do with a single Vault and a single Consul. But even so, spinning that up would require building some new VMs, configuring Chef, possibly setting up some firewall rules. So it's not quite a simple copy-paste from production. We actually did build out a new cluster fairly recently, and getting everything set up there took us a couple of days. Fortunately though, we do actually have a much quicker way of spinning up a cluster that vaguely resembles production, and that's that we have a Docker Compose stack. So we put this together a while ago as a way of testing newer versions of the Vault open source and enterprise binaries in a semi-representative set of local clusters. And we found it particularly useful actually when raising support tickets. We can just say, here, if you run this thing, you should be able to replicate the issue that we're seeing. Sometimes. So we can spin up a cluster. Now we just need to figure out where we're going to run it. Now spinning up a new cluster on our dev laptops is one thing, but we don't want to put production data onto our local machines. And similarly, we don't want to put it in test. Even if it's encrypted, it's still production data. So we needed somewhere in our production network that we could spin this up. And as it happens, we actually do run some supporting services for Vault, and we run those in the same network as the Vault cluster. And all of that gets run in Docker. So that was a pretty good candidate for somewhere we could run it. This would mean, however, that the users whose secret needed restoring wouldn't have access to this new temporary vault, but we could work around that. So, let's see that in action. Now, I've got a local version of Vault running here, which I'm using to reenact what happened when we did this for real. As you can see, it's actually so brand new, I've not even bothered to initialize it yet. Now, taking a look at the console logs, I'm just going to restore one of these snapshots. So I have one console snapshot here. It's from quite a while ago. If I do a console snapshot restore on that, we should see from the console logs that that has indeed restored successfully. So let's switch over to Vault. Now I've got Vault running here with the open source binary, because the secret that we care about is in the root namespace. And we try to avoid using the enterprise binary if we don't need to. And we figured we probably don't need it for this, it's fine. So let's unseal this. Now, 2 of my teammates have already provided their unseal shards. I'll provide mine with my Vault operator unseal command. And, oh, yeah. Yeah, no, that doesn't look good. So this is the point at which, when we were doing this for real, we were kind of worried that this whole plan just wasn't going to work. Maybe you can't take a snapshot from one Vault cluster and restore it to an entirely different one. But then looking more closely at these logs, the error that we're seeing is that it can't cope with namespaces in the map table, which makes sense. That's an enterprise feature, and we were trying to get away with using an open source binary. Oh well, guess we do need an enterprise binary after all. Let's try this again. And you can see this time I'm running with the enterprise version. I'll provide my unseal cut shard. And that is looking a lot better. So the first thing we notice is that there's been a bunch of leases that have been revoked. In this case, these are for tokens. When we did this in production, we saw hundreds, possibly thousands of these. And this is basically all of the leases that have expired between the snapshot being taken and us restoring it. And I've scrolled up and we can see that it's also successfully mounted all of the auth and secret backends in all of the namespaces. But has it worked? Well, I certainly seem to be able to log in. And there's a secret here, which definitely wasn't there before. Now, if you remember, this was an empty, uninitialized Vault cluster earlier. Unfortunately, it wasn't quite this simple when we did it for real. You see, the secret that we wanted to restore wasn't one of ours. It was some other team's secret, and so we didn't have permission to view it. Even as Vault operators, we give ourselves access to the bare minimum that we need day to day, and that means we can't access all the secrets. And it also means we can't modify our own permissions in our own policies to give ourselves access to this. So all changes to policies and auth methods, etc., those all have to go through Terraform. And we can't really point Terraform at this temporary vault for the same reason that the users who can access this secret can't access it either, which is time pressures. We don't have enough time for that. So to work around this, we decided we were going to generate a root token. Now, if you've not generated one of these before, essentially you provide Vault with some of your Shamir unsealed shards, and then you get back an all-powerful root token, with which you can do whatever you like. And so to make that as safe as possible, we decided we were going to have a second person watching at all times, from just before we generated this root token until right after the cluster itself has been destroyed. Now, we were only interacting with a temporary Vault cluster. We weren't technically touching production, but it still contains production data, and the root token will give us the ability to read everything. We could potentially read a secret we didn't need to, or even generate some dynamic credentials. Now, we trust each other on the team, but we shouldn't have to rely on trust. So, we've done this now once before. It worked, and we documented it in case we need to do it again. But there are a couple of things that we would do differently next time. And mostly, that just comes down to trying to avoid using a root token. And there's several ways we could go about that we've considered. Firstly, we'd like to make it possible for the users whose secret needs restoring to access this temporary cluster, so they could get the secret out instead of us. And like I say, we couldn't do that this time because we didn't have enough time to do that. But one of the first things we tried after restoring a console snapshot was logging in with our LDAP users, and that worked. So if we had a temporary cluster set up in advance, with all of that access control, we'd much rather do that. We could also theoretically avoid using a root token by making our admin policy a bit more permissive, giving ourselves access to read all secrets, for example. But like the rest of our Vault users, we only grant ourselves access to whatever we need day to day, and day to day we do not need access to all the secrets. And on balance, we would much prefer to keep it that way. Great power, great responsibility and all that. But there are ways we could elevate our permissions if we needed to. Now, naturally, giving ourselves the permission to modify policies by hand wouldn't be ideal. If we could do that, hey, we can do anything, and we may as well just be using root tokens. But we could make use of an enterprise feature called control groups, and what this would allow is for us to give ourselves temporary access to secrets that we wouldn't normally have access to, just so long as a few people on the team have provided their approvals for that. Something else we didn't consider was network access. So inbound traffic to the cluster, to this Vault, would have been blocked by default, because this VM doesn't normally run Vault. So we weren't actually too worried about that. But what about outbound traffic, say to a cloud provider like AWS? This is something we didn't actually check, and that could potentially have caused us issues for dynamic credentials. Let's say, for example, that someone has requested a short-lived IAM user from just before our console snapshot had taken place, and then they were renewing that lease with Vault. That IAM user could still exist hours or even days later. But if our temporary cluster had access to AWS, because it was restored from this earlier snapshot, as far as it's concerned, nobody's been renewing that lease. And so when that lease expires, it will attempt to delete that IAM user, and then those credentials are no longer valid. And this is something that we didn't even consider could be an issue until quite a while after we'd done this. So thankfully, we didn't actually have any issues like this as far as we're aware, but it's definitely something we need to pay attention to next time. And also, this is just the first time we've done this, so it was an untested process. We were basically making it up as we go along. But we've done it once before now, we know how it works, we know the mistakes we made along the way, and so we can refer to that if we ever need to do it again, and it should go a lot more smoothly. But even though this is now a process that we've done before and documented, we'd rather never have to do it again, please. So there's a couple of things that we can do and you can do to hopefully never find yourself in this situation in the first place. And firstly, and I've hinted at it already, key value version 2. So I still think of this as a relatively new feature, but it's been around in Vault since version 0.10, so that's over 2 years now. It has a number of useful features. I'm not going to go into them all here, but two main ones. Firstly, secrets are now versioned, and what that means is you can update your secret, and the previous version could still exist in Vault if you need to refer back to it or roll back. And secondly, there's now a concept of a soft delete versus a hard delete or destroy. So a secret, or version of a secret that has merely been deleted, can be restored if necessary. Something that was definitely an issue in this case is that the secret was huge. It had 50 plus keys in it. Now, if you're storing passwords for a bunch of related service accounts, it kind of makes sense to keep them in roughly the same place in Vault. But if it's unlikely that a single Vault client is going to need to access many of those at once, do they really need to be in the same secret? So with smaller secrets, not only can you prevent issues like what we've demonstrated today, you can also be more granular in your policies. So maybe you don't want to give out the admin service account password to anybody that just happens to be able to read the rest of them. Also, one of the reasons our users couldn't just recreate their secret by hand is that in addition to having a lot of keys, they didn't have a central record outside of Vault of what keys they had. And so if you don't know what secrets or keys you have, where they're used, how you're generating them, you're not making it easy for yourself. Now, we don't generally consider the existence of a particular secret to itself be a secret, so you could even link directly to them in your documentation. It's also worth taking a look at what your policies grant access to. So you should already be limiting access to who can read and write to secrets, but Vault's permission model is more granular than that. So you could, for example, allow most people to create new secrets, but then only allow a smaller group of people to update existing ones. And this would naturally discourage things like having larger secrets with lots of unrelated keys that build up over time. And similarly, you can grant delete permission to only a smaller set of people. Now, personally, I think separating out update and create like this is a bit overkill for most situations, and certainly it'll make your secret rotation a bit more awkward if there are fewer people that can do that. But there are use cases where that makes sense. So my general point is that it's worth considering what your policies grant access to, and figuring out a comfortable middle ground between absolute bare minimum and the flexibility you need day to day. Next thing is considering your tools. So if you're using the CLI to edit your secret, if all you want to do is edit one key, then with a KV put, you still need to specify the current value of all the other keys in that secret. Now, if we compare this to the UI, in the UI you can just click, edit the key you care about, and then save it. Now, I know as techies we feel like gods when we're using command line tools, especially if we get the command right the first time without looking at the documentation. But the Vault UI is pretty good, and you all should be using it if you can. But for the cases where you do need to use a CLI, if you have a big secret that you need to edit, you can make use of the CLI's JSON mode. So you could read a secret in JSON format, save it to a file, edit that, and then write it back to Vault. And then that way you don't need to worry about copy-pasting all of those keys. Or, if you're using KV version 2, there's a handy KV patch feature that'll handle all of that for you. It's magic. So with KV patch, you just specify the keys that you care about and their new value, and then the CLI will just automatically merge that in with the content of the secret. And that way you never have to worry about having the secret in a file on disk. But we can have all the technical solutions we like, but maybe this is more an issue of education. So one reasonably common issue we find ourselves with is our users confused by the difference between keys and secrets. And that usually results in a pull request for a policy that grants access to secret foo star. And such a policy would grant access to all of the secrets that are prefixed secret foo, but really what the user wanted was they wanted to access all of the keys in secret foo, and such a policy wouldn't do that. Now this doesn't happen quite as often anymore, but it still happens every now and then. So, besides encouraging wider use of things like KVV2, maybe the general issue is just the need to educate our users better. So our users will see our documentation first, before they ever go on to read any HashiCorp docs. So our docs need to be really good, they need to be up to date, and where appropriate, we need to signpost to the HashiCorp docs. It's also worth spending some time with your users, just learning what they do, finding out how they're making use of Vault. As Vault operators, we know the product really well, but watching other users, you might be surprised how many issues or frustrations you didn't know about, or how many things you'd just taken for granted. So before I wrap up, I'd like to take a moment to mention some other storage backends that Vault has. Now, thinking back to the reference architecture, it was using console as the storage backend, and it's pointing you in the direction of console snapshot as your backup tool. But just because the reference architecture uses console doesn't mean you're out of luck if you're using something else. So many of the available storage backends will have their own tools for snapshotting, even if that means doing a disk level snapshot. But I wanted to call out the new Raft storage backend specifically, otherwise known as Vault Integrated Storage. And that's now out of beta as of Vault 1.4. Now with that, you can save a snapshot similarly to how you might do it in console. But unlike with console, when you restore a snapshot, Vault knows that it's happening. And what that means, at least from my testing, is that when you're restoring it to the same cluster that the snapshot came from, Vault never gets sealed. There's no downtime to Vault when it's restored. You could do all sorts of stuff if Vault knows a snapshot is being restored. So if you gain nothing else from this talk, I want you to take away a couple of things. Firstly, help your users learn how Vault works. Be this with your internal docs, any training courses you run, or just helping people out. User error is inevitable, but you can try to minimize the likelihood of it happening. But because it's inevitable, make sure you have backups. That way, you're covered in case you need to roll back or just extract a single secret from an earlier version. And make sure you're also testing your backups. And give KVV2 a try if you're not using it already. Yes, the API for it isn't quite as simple as KVV1, but many of the useful features that it brings more than make up for that. So, the link to my slides are on screen now. If anything from this talk has been useful, I've been Lucy Davinhart and my Twitter's on screen. If not, I'm somebody else and you can pretend you've not seen me. Thank you all for listening, and I hope you enjoy the rest of the conference.